Good day, students. On this clip, we're going to be going over an example on how to use the product rule on three or more functions. But before I go over the example, let's derive the strategy or the formula for the product rule on three or more functions, okay? So let's assume that, let's say we had two functions, f and g, f the g, f multiplied by g, and you wanted to take the derivative. So you know what the product rule is, right? So let's say that the first function is u, this is u, and this is v. Then using the product rule, we know that the derivative of the product of these two functions will be u v prime plus v u prime, right? So that's basically going to be f multiplied by g prime plus g multiplied by f prime. Alright, so this is a product rule that's common that everybody knows about. Now, what if we have three functions? What if we have f times g times h, and we wanted to take the derivative? Now, what on earth is this going to be? Well, if we follow the process, we'll find out that there's actually a cool pattern that we can use to find the derivative of an n number of the product of n functions. The pattern is extremely easy to follow. Okay, so what we're going to do first is derive a formula for three functions, and then I'll show you what the pattern is, and then you can extend the idea for n number of functions, okay? So what I'm going to do here is I'm going to apply the product rule here by grouping the first two functions as one, and then the last function as one, okay? So I'll rewrite this as the derivative of, let's group the first two, f times g, assume this is a function, times h, okay? Now with this method of grouping, I'm going to call the first two functions together. These two, I'll call them u, and then I'm going to call this function v, okay? And I'm going to apply the product rule as stated up here, the one we're all familiar with, to this scenario, okay? So I'm going to go, if I apply the product rule, it's going to be u v prime plus v u prime, right? Okay, so we know that u is f times g, so we're going to write f times g multiplied by v prime is going to be the derivative of this other function h times h prime plus v is h times the derivative of u prime, which is just these two functions f g prime. Okay? Alright, so now we have that. So what I'm going to do now is I'm going to break this one further. We see we have reduced it from the derivative of three functions. Here we have the derivative of three functions, and I'll reduce it to a case where we have the derivative of one function here and the derivative of a product of two functions. So what I'm going to do is I'm going to extract f g prime, and I'm going to find the derivative of that, okay? So extracting these last two functions, f times g prime, what is the derivative going to be? Well, we just talked about it up here, right? Call this u. If I call this u and call this v, then I apply the same procedure again. It's going to be u v prime plus v u prime, right? So the derivative of f g prime in this case is going to be f g prime plus g f prime. All right. Now what I'm going to do is I'm going to substitute this expanded derivative into this position right here, okay? So what's that going to look like? Well, that's going to tell me that the derivative f times g times h prime equals, bring this down, f times g h prime plus h times, now I'm going to change the color so you can really zoom in on what the substitution I just made. I'm going to replace f g prime with its derivative, which is f g prime plus g f prime. Okay? Alright, now what are we going to do next? We just simply distribute this h to these two terms right here. Okay? Now, this is going to become, I can just drop this parenthesis here, f times g times h prime plus h times f times g prime plus h times g times f prime. Okay? Alright, so let me reorder these terms since we know that addition commutes. I'm going to reorder all these terms so that you can clearly see the pattern that's going on here. So if I do that, I'm going to have f, g, h prime. You notice that the first two are left alone, but the last is differentiated, plus f, g prime h. That's exactly the same as this. I just used the commutative property of multiplication to commute this to the center. So you notice that here the central one is being differentiated. And then lastly, f prime gh is exactly the same as this right here. And the first one is being differentiated, okay? So that's the derivative of three functions, f, g, h prime. Okay, so you see the pattern? So all you just simply do is you differentiate every single function exactly once, and you hold the other function as fixed, and then when you differentiate all of them using that pattern, you end up with, and when you sum that pattern, they end up with the derivative of three functions. Okay, all right. Let's extend it. Let's say we have f, g, h, I. Okay, f, g, h, I prime. What is that going to be? Well, that's easy. You're just going to go f, g, h times I prime plus f, g, h prime I plus f, g prime, h I plus f prime, g, h I. That's simply what it's going to be. Okay? Because when we apply the scenario here, we're going to end up, for the first one, we're going to end up with case 3, which reduces to case 2. So this is exactly the pattern that you follow for differentiating n number of functions. Okay, just differentiate one at a time, holding the others fixed, and then you do that for every single term, every single function, and then you sum the collection of functions that is generated using that pattern. All right. So let's apply this whole idea to an example. The task is to find the derivative of the following function. And the function is y equals the natural logarithm of x sine x multiplied by the square root of x. Okay? Alright, so we're going to apply the procedure that we talked about up here to find the derivative of this. So basically y prime is going to be, you hold the first two fixed, ln x sine x, times the derivative of the last one, root x prime, plus, now you hold the first and last fixed, ln x, times the derivative of the middle one, so sine x is the one that will get differentiated next, root x, and then last but not the least, the derivative of the first, holding the other two functions fixed. Okay, so you differentiate one at a time and hold the rest fixed, hold that pattern, and then sum the collection of derivatives that you have using that procedure. All right, so let's go ahead and differentiate these one by one. Root x requires some work, so I'm going to do that on the side here. Okay, so what is root x prime? Well, I can write this as x to the 1/2. It's easy to do it like that. Prime, using the power rule, this is going to be 1/2 x to the negative 1/2. If you subtract 1 from 1/2, you have that. This becomes 1 over 2 to the x to the 1/2, which equals 1 over 2 root x. Okay? So that's the derivative of root x. It requires some work, okay? So I'm going to plug that in for this one. So y prime is going to be ln x sine x. The derivative of root x is going to be 2 root x, so I'll put that downstairs here, 2 root x, okay? Plus, now let's differentiate sine x, that's easy, just cosine x, so we'll have ln x, cosine x, times the square root of x, okay? Parentheses here so we don't get confused, plus, now what's the derivative of natural log? It's easy as 1 over x, right? So we're going to have sine x, root x, divided by x, because the derivative of the natural logarithm of x is 1 over x. Okay? So there goes your derivative of a product of three functions. Okay? And then if it were 4, you can just follow the pattern. You don't even you do not have to even memorize any formula. Just memorize the pattern, and then you do just fine. Okay? So there you have it. Let me box my final result. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel just by clicking up here. You can share the contents of this video with your friends via Facebook or Twitter. More videos can be found on mathgotserved.com. Thanks again and have a wonderful day.